All right, let's take a look at 1.1, rise over run. So before we start the rise over run, let's just kind of have a review of what slope is. You may have heard the words pitch, slant, or steepness. These are all words that describe slope. So for pitch, I always kind of look at a roof. You'll definitely see pitch there. Or slant, again too, you might look at like a wheelchair ramp for slant. Or steepness, sometimes you might think of say a mountain, or going down that double black diamond. So that's what slope is. Slope is a ratio that compares the change in a vertical distance. So when we look at vertical, what we are talking about doing there is we're looking at up and down, right? That describes vertical, and the change in the horizontal distance. So the horizontal distance, we're both basically going left to right. So slope is usually written as a fraction that can be expressed as follows. Slope equals, there's a little fancy triangle there. That's just a fancy symbol. It's a Greek symbol that stands for delta, and delta means change. So if you look at the end of a river, it kind of changes into all these little tributaries there, that's the word I was looking for, before it goes into the sea or to the ocean or whatever. So that's what the triangle means. It means delta. So the change in the vertical distance, so going from here to here, and the change in the horizontal distance, that means going from here left to right. All right. So in most cases, the variable m is used to represent slope. I looked it up, kind of why, and one of the interesting examples I found for using M is there's a French word, and excuse my French here, but it's basically monter, which means to climb. So if you think climbing up a mountain slope, that's why they use the letter M. But you can use X or other variables too, but M is usually what's used the most. So the change in the vertical distance is called the rise. All right, so we're looking at the rise here. And the change in the horizontal distance is called the run. And that means we can express the slope more easily as m equals rise over run. So in many trades, calculating the slope is necessary in order to ensure that designs are met, building codes have been met, and structural integrity has also been met. For example, the building code that states that the decks must slope 1/4 of an inch for every 12 feet on a deck to drain water away from the building. Actually our city has a bunch of bylaws that talk about this. So when you get a building inspector and you're trying to sell or buy a house, if your say your deck, for example, like that isn't up to code, you can't sell or buy that house until that's met. Well, I guess you can buy it, but then you'd be responsible for making the fixture. So that might be something to do. So definitely slope has a lot of practical applications to it. So we can see here a contractor may be asked to build a ramp to make a house wheelchair accessible. Why would it be necessary to calculate the correct slope of the wheelchair ramp? Well, if you look, pretty soon I have a 3-act math play that I want you guys to do that will definitely explore this. So keep this in mind and keep in this formula rise over run, as we will do that later on. So I'm gonna just kind of skip the rest of this part for now, as the 3-act math play I think will help you understand that a little bit better. So let's take a look at rise over run. So again, like we said, the rise is the vertical change. So if I gave you a little diagram like that, that's what the rise is, and the run is the horizontal. And we're going to look at different types of slopes, and how when you change rise and run, how that can affect the steepness. And I'm hoping down the road that we'll also do a Minecraft activity where you build a roller coaster, explore this even more. So the horizontal, again, would be left to right. So slope is, like we said, it's the pitch, the steepness, all right, or the slant, and basically it's the change in the rise over the change in the run. Okay, so hopefully that helps you out. And then you can hopefully now see why we did the other section here too, and really try to understand fractions and proportions, because it ties so well into all three of these concepts: rise, run, and slope. So If we take a look at example number 1, a section of the Kootenay Pass in southeastern British Columbia, actually drove through there, gains 610 meters of elevation over a horizontal distance of 12,100 meters. And a section of the Coquille Pass in south central British Columbia, don't think I've been there yet, has a gain of 845 meters over a horizontal distance of 19,888 meters. All right, so again, we have to figure out the slope, which is steeper. So what has a slope? So we're going to use that formula that we talked about, m equals rise over run, for both of these. So when we look at the Kootenay Pass, we would have 610 meters over 12,110 meters, and we got to figure out what the slope is that. So I'm going to bring up the calculator here, bring that into view. All right, my handy dandy calculator, and we're going 610, and we're dividing that by 12,100 meters. And that's going to give us about, as you see there, it's a, oops, go back, just get right, about 0.05. We'll round that off. So 0.05. Now, a really important part to know with slope here is that there is no units with it. So these meters divided by the meters would actually equal 1. And another key thing to keep in mind when you're doing this is always make sure you have the same units when you're dividing. If one is centimeters and one is meters, you have to either put them both as centimeters or both as meters, whatever you choose on that. But you have to have the consistency here, and you do have to, I don't like the word cancel out, because cancel means 0. So I really like the fact that meters divided by meters is 1. So when you times 1, anything divided by itself is 1. So when you times that, that's why you get the slope here. When we look at the Coquille Pass, we have 845 meters over 19,880 meters. Again, see the meters there would definitely divide into 1. I'm going to bring up my calculator, and I'm going to clear this and put the 845 and divide that by 19,880, and I'm going to get 0.04, basically 0.04. So on here, when we go back, thank you, Mr. Calculator, 0.04. So you see that one was how we did that. We figured out the slope for both. And again, the closer you can get to, like, the bigger number in here would have the most steepness. So that would mean that our friend here at the Kootenay Pass would definitely have a steeper slope. So be careful. If you're a truck driver, that's huge. That's talking about how much gas you're going to use or how your brakes are doing, all that, all real life examples when you think about that, when you look at slope. You know, how you're going to build tunnels, how you're going to do road construction. Those are critical, you know, those could be life or death, you know, if you're not too sure what's going on. So to fill in some of these missing works here, right, again, this is why we looked at the first part. If you look at this first part on the graph here, or chart, sorry, we remember we're going to use m equals rise over run for all of these. So when I look here, I know my slope is 1/4. I know my rise is 7 inches, but I don't know my run. And again, like we talked about before, that's where the cross multiplying really comes into play. And this one's a little bit not too bad. We got x times 1 equaling x, and 4 times 7 gives you 28. Here we have inches, so you can't forget to put the inches inside of there. So this here would be 28 inches. Okay, hopefully that makes sense. Let's take a look at one here with the missing rise. It's the same concept. It's giving us the slope, so we're going to put down 7/3. Now, this time we don't know the rise, but we know that the run is 21 meters. Again, here's where you cross multiply. You're going to get 3x equaling 7 times 21, that's 147, right? And don't forget, that's meters. Now we have to isolate the x. You can see why the previous section was so important. So we're going to divide both sides by 3. I'm going to bring up my handy dandy calculator, right? And I'm going to go clear that, and I'm going to go 147, and I'm going to divide that by 3, and that's going to give me 49. So x equals 49 meters. Okay, so I could put 49 meters. Again, another way you could look at this is, here's 21 meters. Well, what did I times by 3 to get to that 21? Well, I times by 7, right? So I have to, if I times the bottom by 7, I also have to times the top by 7, and 7 times 7 is good old 49. So there's another way to look at it. So depending on whether you're trying to find your run or your rise, will definitely help you out. Okay, I'll complete the rest of the chart because I think you have enough information to do that. But again, if you're having any questions about that, please let me know, and I would be more than happy to help you out. Give me a text, give me on Remind, or send me an email, or come see me face to face. So again, you can see how slope can be used in construction. I'm going to skip that one, and let's just take a look, because this one here will kind of help you maybe with the 3-act math play we're going to look, and it's a good one to think about because, again, another really great real-life example. So let's pick this apart. Duncan and Casey are using dollies to move small boxes from a house to a garage. They lay a loading ramp against the house steps, which are 18 inches high. So when I see the word high here, that's going to give me an alarm like high. I think vertical, right? Like high. Like how high is this? So on here, I'm thinking here that the rise is going to be 18 inches. Okay, it's really important that you be able to decode this, and this is a great lifelong skill. The slope of the ramp is 0.02. So when I'm thinking about my slope here, my slope is 0.02. So I got to figure out what the ratio is. So the piece of information I don't know that I'm trying to figure out is my horizontal distance or a run. Ooh, in feet. So that's going to be a little bit of an interesting thing, because if you look here, this says inches. So this is what I was talking about before. You have to have things in the same unit in order to be able to do this. Alright, so let's have some fun and let's do this. Maybe we'll make some mistakes along the way. If we do, that's okay. If we don't, that's good too. So this is what we're trying to find out. Okay, we have 2 pieces of information. We have to find a third. We know our formula is m equals rise over run. So we have that. So I think we have everything we need to try to solve this. Let's give it a go. Okay, do we have an m? Yes, we do. So we put down 0.02. That's a really important piece of information. Now, because it says feet, I'm going to take this, and I realize that there's 12 feet, right? 12 feet. Well, there's a mistake, right? Let's fix that. There's 12 inches equals 1 foot. So if I have 18 inches, if I go 18 divided by 12, I get 1 foot, and then 6 over 12, which is about 1.5. So I'm going to use 1.5 feet, okay, as my rise. Okay, hopefully that makes sense. It's really important that we do that. If you notice here, this said feet, oops, and this said feet here as well. Okay, maybe I'll erase that so you can see the feet in there. Okay, good. Let me try to highlight that. Boom, oops. All right, so again, feet, this had to be feet too. All right, so when we go here, I know this, my rise is 1.5 feet, but I don't know what my run is. Okay, so again, if you remember, if it helps you, do this. You can put this all over 1, so when you cross multiply, you see that there is a denominator of 1. Okay, crisscross applesauce, right? Do a little bit of cross multiplying here, so I get 0.02x equals 1.5 feet, right? Because 1 times 1.5 is going to stay the same. I want to isolate this x. Remember, this is 0.02 times x, so the opposite of timesing is dividing, so that's going to be 0.02, and what you do to one side of the equation, you must do to the other side. Just like life, you got to have your balance. 0.02 divided by 0.02 gives you 1. 1 times x is just x. Now I'm going to bring back my handy dandy calculator in again. Clear that off. Go 1.5 and divide that by 0.02. And that gets me 75. All right. Thanks, calculator. See you later. And there we go. 75 feet is what my my run must be to do that. So hopefully that made sense. That's one of the tougher questions too, especially when you have to do you know, your conversion here and change them both into feet. So it's really important that you read, you understand the question, you draw diagrams, decipher what it's asking for, and you can definitely do this. It's great problem solving here. You can see how you could use that a lot of times in life. So that concludes our video for 1.1, Rise Over Run. I hope you had some fun. Until next lesson, take care out there.